All right, this is the last example of chapter 6, question 122. First, let me read the question. Blue light with a wavelength of 450 nanometer is shone upon two slits. The distance between the slit is 6 micrometer, and the distance between the slit and the screen is 2 meters. First, let's write down the relevant information. We're told that the wavelength is 450 nanometer. The distance between the slit, this distance over here, is 6 micrometer. The distance between the slit and the screen, this one over here, is 2 meters. All right? Now, at first, what we are going to do is I'll draw the diagram and explain what each of the parts are. We want to find, in part A, what is the distance of the first fringe from the central maximum. In other words, we want to find the height over here. Now, we know from the previous example that we have a relationship between the angle over here, the wavelength, the fringe number, and the distance between the slit. So we can use that formula to get the angle over here. Once we have the angle over here, this forms a right triangle again. So in this case, we will use the tangent, the opposite side, divided by the adjacent side. All right? So first part, we got the formula over here for that link, the distance between the slit, the angle, the fringe number, and the wavelength. We need to manipulate that one to isolate the angle. Now note, I added a subscript M over here because we're going to be using it twice, so might as well get a general formula. And we just plug in which fringe we're considering. In this question, it will be fringe 1 and 2. So we got our formula for our angle. Now the second formula, tangent of our angle, is equal to the opposite side, which is the height we're looking for, divided by the distance. And again, here we're looking for height, so let's isolate that term. Now, in order to complete the question, I will need to erase some material on my board. So pause the video, write down what you need to write down, and I will be erasing the top part over here. Right, so part A, we need to be finding, for part A, we need to find the angle. So the angle with M is equal to 1 is equal to the inverse sine of M, which is equal to 1, multiplied by the wavelength, 450, multiplied by 10 power minus 9, divided by the distance between the slit, which is 6, multiplied by 10 minus 6. This value will give us an angle of around 8.6 degrees. All right, now if we plug these values in the formula over here for the height, and considering that the distance between the slit and the screen is 2 meters, we get a height of 0.303 meter or 30.3 centimeter. All right, that's part A. Part B asks a very similar question. The only thing that changed in part B basically is this term become 2 instead of 1. So part B, second angle, sine of -1, 2 multiply. And in this case, we get an angle of 17.46 degrees. All right, let's find the height in this case. So same logic, D multiplied 10. Now, obviously, we use the second angle in this case, and we get a height of 0.629 meter. So that's the answer to part B. Part C, we are asked, What is the distance between the first and the second fringe? Well, this question is very straightforward. Basically, we simply take the answer of part B minus the answer of part A. So y2 minus y1 is equal to 0.629 minus 0.303, and we get 0.326 meter. All right, so the question is fairly straightforward. We use different technique in order to solve it. It take a bit into account everything we've seen so far. So it's a really good question. We are done with the example of chapter 6. Make sure you work on the exercise and do not hesitate to ask for help if you get stuck somewhere. All right.